Hey everybody, this is Larry. This is August 24th. Well, it just turned to August 24th here in New York City. Here I'm going to try to do an extra problem that I've been done before. We already did a hard problem today, so I'm just going to just do a medium or easy. I do both? No? Okay, let's just do a medium problem, an RNG one that I haven't done before, just to kind of keep my fingers sharp, so let's do it. I already clicked on it, right? It's grayed out. So we'll see what random problem we get. We get, hope everyone's doing okay. I don't know why it's loading so fast. 1983, widest pair of indexes with Leetcode range sum. Could be interesting. You're given two zero index binary arrays, nums1 and nums2. Find the widest pair of index comma j such that I is less than or greater than j, and nums of I plus 1 all the way to j is okay. So basically, so basically the sum subarray sum is equal for some I and j. Okay, the widest pair of indexes okay. I mean, I think this is relatively interesting, right? I think another way to think about this part, I mean, this is kind of, I wouldn't say this is hard, but it is definitely not easy. And I would also say that this is only not hard because there are so many similar problems on Leetcode. So in a way, like if you do enough Leetcode, which I have obviously, then you would have came across similar problems, right? And then it becomes easy because you've done similar things so many times. The key thing about this one is that, so you have this function, right? You have this function. Another way to write it though is that if you kind of just subtract this side, I mean, it's just very easy, right? To subtract that from both sides. So you have that is equal to 0, right? And then now what does that, and then now you could rewrite this as, I mean, I was just lazy on the whatever, but if you kind of distribute this thing, then now you have plus, minus, right? So subtract on the other side. And then now if you want to rewrite this, then you have basically nums1 sub I minus nums2 sub I plus nums1 sub I minus nums2, I plus 1, sorry. But you knew what I was going for, hopefully, right? Plus nums1 of j minus nums2 of j, right, is equal to 0, right? And of course, we're given all of these immediately, so we can just create a new array where maybe it's array sub 1 plus array sub I plus 1 plus array of I plus 2 plus plus array of j is equal to 0. And of course, this formula, right, is what we're trying to find for the longest, the widest I and j, or whatever they call it, right? And the way to get this, the one way to look it up is, of course, with prefix sum, right? And this is, I know if I sound a little bit too whatever, it's because, like I said, this comes up on Leetcode all the time, or enough of the time that I don't think this is easy, honestly, but if you're given the same problem enough times, it's going to feel easy because you've seen it before. And some of that, that's why you practice. Anyway, with prefix sum, you get to say prefix sub j is equal to array sub 0 plus array sub 1 plus array sub 2 plus plus array sub I plus array sub I plus 1 plus plus array sub j, right? So that's just like regular prefix sum stuff. And then your prefix sum of I minus 1 is equal to basically the same thing, right? Except for it goes up to, maybe I should put it right here. I minus 1, right? So then now if you kind of write it this way, then now prefix of I minus 1 is equal to just this thing. And then of course, because I don't need this. And then of course, prefix of j minus prefix sub I minus 1, did I say that wrong? Is equal to this thing, right? is equal to this thing, which is equal to 0, and that is what we're trying to solve for, right? For whatever. And then now, then we'll go over the loops, right? So n is equal to num sub 1. You don't have to do this explicitly, but I'm going to do it just for illustration purposes. Like, you probably could do it in one thing if you care about it, but you can do something like for I don't know, x1, x2 in sip of nums1, nums2, right? You could do array dot append x1 minus x2, and of course this is what we said, right? I mean, yeah, right. Like I said, you don't need to do this explicitly, but yeah, we're doing it for fun. And then now we have prefix is equal to, it starts at 0, and prefix something. I'm not gonna go over it in this video just because there are enough videos where I do go over it. I'm a little bit tired today, my apologies. But yeah, but this is just prefix sum, you know, array of 0 plus array of 1, or right? And this is all that does. It's a little bit off by 1 technically speaking, because there is the no array, right? Because what you want is that prefix of 0 is just equal to 0, which is what we have here. So technically, I guess this, and prefix of 1 is equal to array sub 0, right? So that's like by convention. So technically, this is plus 1, but it's just a little. If you want to write it this way, it may be a little bit more precise. If you're off by once. So yeah. So then now, yeah, you have this as the prefix sum, right? And then now we have to find I and j. Of course, if you just do a for loop and I and j, that's gonna be too slow. N is 10 to 5th, n to the 5th, so n squares n to the 10th, right? So then now what you want to do is just as you go by the prefix, and technically you don't even need this array either, because you can store it up, which is that we want. What does this look like? Let's rewrite this real quick now that we understand this, right? So then prefix sub j plus 1 minus prefix sub I, right, is equal to 0, right? Is what we're looking for. If you kind of just add back prefix sub I on the right side, then now you're looking for this relationship, right? So you're looking for, in this array, you're basically looking for two things that are similar from I and, or exactly the same, sorry, not even just similar, I and j plus 1. In this particular case, we want to maximize the difference between j and I, because that's what they ask you to do, right? So yeah, so basically that's what we were trying to do. So then now we can do a lookup thing, right? I'll just write it separate out. So then now for x in prefix, I guess technically we should do enumerate so that we get the index. So then now for this, we can say lookup of x is equal to index kind of, because here we want to make it as wide as possible. Then what this does is set up lookup to be as earliest as possible, right? You can actually separate them out into two different loops, but I think that in general you should have in one loop, because there are different things that you may encounter. Like in this particular case, it doesn't matter, but you know, yeah. So then basically, yeah. So this should be as earliest as possible, which means that we only care about it if it's the first instance of it, which is that if x is not in lookup, right? So then this is what happens if x is not in lookup. Otherwise, before that, this loop is going to be actually the j loop. So yeah, set this. Yeah, I mean, we can just do a comparison, right? So best is equal to 0 is what they want anyway. So then now we have best is equal to max. If x is in lookup, right, then best is equal to max best, or the current thing, which is the index, right? The current index is going to be the j minus lookup sub x, which is going to be the I. I think this should be plus 1. Maybe I'm off by 1 there, but either way, yeah, that's pretty much it. Okay, so I am off by 1. Cause wait. Not true. Why is that? Do index. Just want to make sure that I understand it correctly. Distance between indexes. Yeah, I mean, I think that's mostly it, though. Yeah. 0. Oh, yeah, okay. Because we're storing I and we're keeping j plus 1, so maybe that's why. Okay, let's give it a submit. Hopefully I don't have a silly mistake with a wrong answer. Yeah, looks good. A little bit slow though, actually, to be honest. I mean, we can optimize it a little bit, right? But I just wanted to show you like why everything kind of follows through. But yeah, and everything with this, this was pretty cool. 10 minutes is okay. But yeah, so what's the complexity here, right? Well, this is linear, time and space, and this is linear time and space, and so everything's linear time and linear space, so we should be very Gucci. There are a couple of optimizations you can do. For example, we don't need the separate array, which is what I said. I mean, you know, yeah, you can just do something like this, right? And then now it's going to be x1 minus x2. Yeah, I know that you don't need the parent, but just, you know, yeah, submit. Maybe it's slightly faster. Shouldn't be that much. I'm actually surprised. Oh, apparently that already kind of changes the thing a bit. And then the other thing is that we don't even need the prefix array, it turns out. We just kind of, because we go through it anyway, right? So then now we can just go through this by enumerating this. We have index, right? And here instead of prefix, we just set up initially 0 is equal to 0. The reason why we need this is also because it gives you this thing, right? So that you subtract it as the I on the left side or on this right side will be 0. So then now it contains the element array of 0 to be subtracted out from it, if that makes sense. But yeah, and then now let's just say x is equal to x1 minus x2, and then we should be good. Right? Oh. If I could spell, we should be good. Right? Dun dun dun. Oh, yeah. Did I run it? I'm trying to think why this doesn't work. I mean, I know why this doesn't work, but I'm surprised that this doesn't work. But this is why you have to factor in all these things. The reason why this doesn't work is because this is returning a 0. So maybe I just got lucky on the other one and that it happens in multiple things. But the index is off by 1 because we don't have prefix element 0. So here maybe we can just do. Now we need to, because then now it also like just double zeros. So it's a little bit awkward. I should have checked that though. I mean, I kind of noticed it as I was submitting it, but it's a little bit, I've been going a little bit fast. Ooh. I think the enumerate has a starting thing, but wait, let me double check real quick. I'm pretty sure it has a start thing. Okay, so apparently it does. I thought there was like a named variable, which I prefer, honestly. But okay. But why is this? Why do I return 2 on the second one? Oh, I'm dumb. I see. I mean, the index is just what. So the funny thing is that maybe we just got really lucky, or as a result, unlucky, because this is just really wrong, right? What we want is the prefix, not the x, and this is the x, not the prefix of x. So then now we want like prefix is equal to 0, right? And then now this is x, but then now we want prefix, we want it at x, and then now this is going to be the prefix, right? And this sets it up for the future. Yeah, okay, wow. So we just kind of got lucky with the indexing before in it's just kind of wild. Yeah, it's a little bit slower somehow. I don't know. And apparently the difference between that 100 meters is like a lot of the percentage. That's why I kind of did the optimization. But yeah, as you can see, this is pretty okay, right? Yeah, I mean, you know, that's pretty much as I can get. I mean, you can make this an else statement or something, but that's so that in theory, it cuts off everything. But it's just, I don't know, as fast as I could get it, probably. As clean as I can get it anyway. Don't know why it's so slow. I mean, I guess you can, yeah, like you can get rid of the max thing, but I don't know. Right. But these are just micro optimizations. I mean, this is linear time and linear space. It's, you know, yeah, I mean, it's kind of wild that everyone has the same performance, because just like about 100 meter readers is like 5%, 86% or something. Anyway, all right. I mean, that's all I have for this one. I'm not gonna go abusing this that much more. Yeah. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.